good morning to the SVS Academy School. It's our third webinar. Today we will talk about two parts as usual. The first part we will talking about the working life in the time of construction and materials, and in the part two we will have our guest Eero. He will talking about axial load connection. Before I started, I just want to pull up a question to see how many of you have been in the webinar before, in SVS Academy webinar before. Please just answer this question. Is it finished here? No.
Yeah, in chat field, I think at least I will see that response are coming in. 15 have been answered, and everybody can see the statistic as well, I think, on a chat field area.
We have almost 47%, which were not with us before. Therefore, if we go further and talking about the webinar, because we have very short time, I think it will be 2-3 minutes about intro, about a little bit about SVM, and then after that, Enno will talking about the lifetime materials, and after that, Eero will talking about axial load connection according to the Eurocode. And after that, we will have 5 to 8 minutes feedback and poll question. If you have questions, you can please write it here down in the chat, or after we finish, you can just ask us. We will try to answer you. If we don't have answer, we will prepare to the next time. For whom, for the 47% will not be with SV before, just very shortly, that SV is the leading fastening company in the Nordic. It's founded from 1917. It's almost 55 years ago. We have office in several countries, and we are more than 200 employers. To imagine how big SV is, we sell almost 5 million screw in a day. Our primary application, we have 4 primary application. Maybe your structure engineer you not have recognized, but the main part is this one, which is activated by green line around, is foundational structure, which is almost structure can find what product that they need in this part. We have the building enveloper and interior finishing and outdoor, but I think we, for like structure engineer, we have most focus on timber structure and glulam and CLT. Yes, it was some few words about SVM. I leave the presentation to my colleague Enno. Please, Enno.
Thank you, TR. I will take over and share my screen. And yes, you were in this part. I will bring also pen, and let's go for it.
Yes.
Today we're talking about working life, and working life of building materials is the focus. The fastener part of working life will come in June, in before summer holidays, so we will jump in there. in June, coming back. But I will raise just maybe a pressing question here that if we talk about working life, then we know that there is a short, medium, normal, and long, which is measured like short is 10 and long is 100 years. And I will raise a poll question now in the side where I will ask that what is the expected working life of fasteners? And you can give your feedback. Feel free to answer the feedback. You can put it on a way, and then you will see how does it come or what does it gonna be. We will look at that more closely in June. Then I will take the slide who have already answered or haven't answered. Then step and feedback is that actually these are 25 years. And the question is, how do we come to that 25 years? If we look in the table from category of design service life of buildings, then that's the picture what architects often looking at. And from architectural point of view, they are looking normally at buildings which are either one medium life, 25 plus years, or long life, which is residential buildings, it's a 50 plus years. But how do we get the facade application to the 25 years, for example? Then that is another support picture. And that part is coming from expected service life of works of construction products. So this is the product part, and there is also a table 3.3 who wanted to go in, and the link is below, is design of life construction components. And why I bring that up as an important issue on a discussion point is that normally for engineers who designing and following this table, looking 50 years, we know that the 50 years is lifetime works. And I recommend to use in a project descriptions normal. If we write in 50, then all applications are automatically 50 years. But if we write in a normal, then for the construction aspect, we see that less easily or repairable or replaceable areas are 25 years, and repairable or easy replaceable areas are 10 years only. And as facade belong to that area, then the working life of facade will be 25 years, for example. And when we look into the fastener part, also our full system EAD document side in June, then we will see that will confirm it. To go forward on fastening point of view, then when we apply CE marking for our products, fasteners, then normally we follow EAD document, we're gonna get the ETA, and or we're gonna follow the harmonized PN standard. Then there is the same as for the products. The normal means years, 50 years in lifelong as well, but the description of repairable or easily replaceable is similar, 25, 10 years. And that's why when we call in a project normal, you are more safe, you make your project more competitive, and we can be more flexible looking products and the working life with competitive product in that area. Taking a step forward, if we go to look at the massive timber area, the normally the structural works is always 50 years. And that was not the subject we were talking about today at the moment on facade content, but structural work is always 50 plus years. And we know that there is also different timber materials in working areas. And that could be a CLT, or it could be a LVL, or it can be a glulam, GL part. And I have here also another question to raise you as a poll. And this poll I will ask you, I will raise it up. Let's see, coming now. And this poll, we talk about it, just a moment. Here we go. Name correct timber connection working life influencers, because we have a different influencers. Here you can have multiple answers. So if you know, feel free to give answer. But it's a good educating point just to see how do we think and what do we see as an influencer for timber connection working life. And you are free to give here more than one answers, and you can go for it. But I will go forward with the presentation. You will see what's coming up here, and I will switch the screen for myself and go step forward. What I wanted to explain here that inside of the different service classes or environmental classes, we have different influences, and one of the influencer is also timber itself. And according to the new EN 14592, there is a description depend on the humidity level. And if you see that the humidity level timber class 3, we have a variable wood mentioned here. I brought here a sample of Latvian text of different woods as a translation. But we should think about it when we exceed over the 60% humidity in or moisture in wood. And then the wood starts also playing a role on his pH level to the metal connections. So that is important to know. And stepping forward, then there is a different also connections when we talk about brackets. We will bring it in, or we do cross fixings, often done with the harmonized products or ETA approved products. We go on angle fixings. And here is also different wood materials also treated on external environment. And I would like to think about how is the influence of the treated timber will go towards to the metal applications, fasteners, brackets, and so on. And for that reason, I have set up a table just from the area where we'll raise also a question that are you ready to put where the steel, aluminum, copper, and stainless steel will located in corrosion table. And why I'm talking about it, because after the copper is as a material in impregnated wood, and in impregnated wood, the copper makes the wood life longer, but it also influences to strongly to the fastener working life. Question here, which group we locate next metals? And that is now for you to give us a feedback. Is it steel in a group 3? Is it aluminum in a group 2? Is it copper in group 5? Or is it stainless in group 4? And that's up to you to give the feedback. You will see here the answer now. I will come to the presentation part, and the question is done. You have done your poll, and when I bring up the answers for you, then you will see that aluminum is aggressively influenced by carbon steel, but even more strongly by stainless steel and copper. And as a copper is the highest level, then we always in impregnated wood area to come to the 50 years working life should choose external environment, the stainless steel fastener. If we go for internal application, then normally in that area we don't need an impregnated wood. And for that reason, the neighbor materials are very good to use each other. If you're going to have more questions, feel free to ask those questions in the future. We will come back to you. But that was the part what I would say, that pay attention of the copper played in role in different connections and think about the connection working lifetime. Last sentence and message that in before the CPR time, which was in let's say 2012, there was also mentioned that in fire reason, in case of fire, bring in the specification of product. And here's some brand names of the specification of ESVE. So you will find that as well. So I'm not gonna go that through, but we will find the cylindric head, double thread, hex head, flat WAF heads, and so on from ESVE assortment. But yeah, this is it. And think about it, the working life, and the day's lesson is that use a word of normal instead of number of 50. Thank you from my side. And I think that we go for the next presenter, which is Eero.
Hello. I will share my screen. Can you confirm that you can see?
Yes, we can see it.
Thank you.
Yeah.
Okay, for those who are here first time, I'm Eero Tuhkanen from Taltech, and we have a nice cooperation with ESVE to introduce the new Eurocode, coming Eurocode, and we decided to make that with very short presentations to not overwhelm you. And today's topic, which I cover, is actually loaded fasteners, and this is the first part of actually loaded fasteners presentation. And today I'm focusing on actually loaded fasteners in laminated timber. This is something to consider in the new Eurocode, and it's not available in the current Eurocode. But if you get in some or 2 years the new Eurocode in your hands, you can find there new materials. Most or many of them are layered materials like cross-laminated timber or LVL, and also in new Eurocode there are new fastener types which are covered now only in ETAs, and now we can find everything in the one document. This calculation in layered products is, let's say, quite complicated because we have to consider different angles which are defined for layered products. There are, for example, angle between the direction of the force acting in the shear plane and the grain direction. So we have to consider always the grain direction. And there are angle between the fastener axis and the surface of the white face. So there are different angles, but the most important regarding today's topic is the angle between the fastener axis and the grain direction, which influence the pull-out strength of the fastener. And the formula in the coming Eurocode for axial tensile resistance is considering both timber part and also steel part. We have to also check the steel strength and the timber part. We have to check the pull-out of the fastener, and sorry, not the pull out, but pull through, the head pull through from the material and pull out. And the pull out of the fastener includes this specific parameter like the characteristic withdrawal resistance will consist a specific parameter which is called characteristic withdrawal strength. So this formula is similar to the old or existing Eurocode. We have to consider the diameter of the fastener, then the embedment strength, so how long is the part in the timber, and then this characteristic withdrawal strength. And this is defined in a new way in the new Eurocode. For staples, this is also the formula for that, but today we are focusing on the screws. The characteristic withdrawal strength, this specific parameter, has many influencers, and the influencers are marked with different factors: K screw, KW, K mat, K row. And if we look at them closer, this K screw is the factor for characteristic withdrawal strength. It considers the diameter of the screw, and it's meant it's this reason why it is in the standard is that we have to also consider the ETA, but this K screw factor, I will talk about this later in June, more specifically, but the parameters you maybe know already better are the parameter for the angle between the fastener axis and the crane direction, which I mentioned earlier. Sometimes the producers are giving the result where already this angle is considered, but in the new Eurocode there are the formulas which you can use to consider the angle between the crane direction and force angle. And of course, reference density exponent, if we calculate the withdrawal capacity, we have to consider the timber class, and different timber classes have different density, characteristic density, and this factor will consider that. But today we had this topic which I bolded was characteristic withdrawal strength in laminated timber, and this is something new we don't have in current Eurocode is the factor K mat, and the K mat is considering the number of laminations, and it's because of today the screws can be very long. We can use the screws for reinforcement, and also we have many layered products, and if we make the connection in that way that we go through many layers, so this will increase the characteristic withdrawal strength, and this is covered with this factor K mat, and we can increase the withdrawal strength up to 15%. This is mainly based on the work made by Andreas Ringhofer from Graz Technical University, And this work shows, this doctoral thesis shows that if we go through more than one layer, then we can have higher withdrawal strength. So this is something you can consider. Next time I am covering the actually loaded timber connections in compression, and in this presentation I also show how or in which situation you can benefit from this K-mat factor, where it does have an influence. So this is all from my side.
Thank you, Eero.
Thank
It was as a search engine, I think it's not too easy to have control over all the connection which you have in a building. Maybe you have more than 50 or 100 connection and in different direction.
Yeah.
Maybe we will prepare the one summary webinar that we go through the questions, general question about how a structural engineer can guarantee that when he calculated one or two connections that he have control over all. Maybe we will have it like last webinar before the summer. For that, we will be appreciated if you have a specific question, or if you have some problem, or if you have some case, you can send it to us, to me or my colleague Eno, and it will be unknown. But just we want that we have time to prepare the right answer to give it to you, and it will be knowledge for the others. Yes, that was just small information about how we thinking in Yeswood, that we want to share knowledge with all the construction engineers, so that we help each other. Please, Eno, can you pull up the next questions, and I will share my desktop again.
Yes, I will do that. I will go for,
okay.
You mean poll feedback questions, I can rise it up, but in the same time, everybody, you are welcome to put your questions to the chat field. In a chat field, I have raised one question also for the Eero, but that is just as a feedback questions for before the end. But yeah, I will raise the question to Eero. Eero, have you found the question?
Yes, I have found it. You asked about the secure connection. So yes, we had a couple of webinars ago. I talked about this safety in the connection, and safe connection means that it has certain amount of ductility, and in the pull-out we can also consider steel as a deciding part of the failure, and if the steel is deciding, then it also has a certain amount of ductility. So yeah, we can design also the screws in a very tactile way to ensure secure connections.
Yes. Thank you. And we have just a minute. I will just remember you that our next webinar is 8th of the May and 22 of the May. But if you have question and some concrete case, just send it to us, so we have prepared for the summary webinar that we go through the webinar we had it before, and talking about special case, how you as like a structural engineer can be guarantee you have your connection under control. Yes. And if you have questions, you can contact one of us, maybe in Nordic. I'm sitting here in Poland, my colleague Radi, his telephone number and mail And for Baltic countries, you will contacting my colleague Enno. Yes, thank you.
I have maybe one more feedback before we end. I will share my screen, and as I made several so-called poll questions on that, then I will give you just light feedback that first time the day was a 15%, last time was participating 41, 44 was already taken part of all of it. In first third question feedback, just roughly 50% put it in right area, so 25 years is right. When we were looking the influences on the timber, then all of them are correct. So there was a service class, environmental class, timber treatment material, and also what kind of timber is in use. And that what kind of timber in use, we see the percentage, how the answers came in multiple way, and which group of metal is right. Mostly steel was and aluminum was put it in the right place. Here some mix up of copper and stainless a little bit lower, but that's today's feedback. So thank you very much everybody who have taken part of this academy, and we will see you already next time.
Thank you. Bye bye.
Thank you. Bye.